Hello everyone, welcome back. Today we are going to solve this daily challenge from LeetCode course schedule. So in this question we have been given n courses numbered from 0 to n minus 1. Then we have been given an array prerequisites. So basically it is a 2D array and each of the arrays inside this array itself is an edge between two nodes. So basically if there is a pair 0 comma 1, so we can say that 0 is dependent on 1. So this forms an acyclic directed graph, and we need to check whether we can visit all of them um, in the order they are dependent on each other. So just for example, so this is a very simple example of a directed graph. So we will, what we need to do in this question is topologically sort the nodes or the courses that we need to take, and we do that on the basis of whether the course is dependent on any other course or not, and if it is, then if it is taken or not. So for example, 0 here is not dependent on any other course, so 0 can be taken anytime. Then 1 is also not dependent on any other course, so it can also be taken. And once 0 and 1 are taken, we have covered the prerequisites of 5 and 4, and we can see that 4 is not dependent on any other prerequisite now, so 4 can also be taken. And 5 still needs a prerequisite course, that is 2. So in that way we can do this. So there are two approaches to topologically sort, as you all know. So one is DFS, the other is BFS. The BFS approach is called Kahn's algorithm, which we are going to make use of in today's solution. So we'll start by counting the in degrees or the number of dependencies of each graph, each node. So for example, 0 is not dependent on any, so it becomes 0. 1 is not dependent on any, so it becomes 0. And we can see there are two outgoing edges from 4, so it has two prerequisites. Similarly, 5 has 2 and 2 has 1 and 3 also has 1 dependency. So we'll keep on clearing these dependencies. So if, for example, once 0 is done, then 5 needs just one more dependency to cover, and which is 2. And here 4 has all the prerequisites covered by when we solve 0 and 1, so it becomes 0. So we will keep on decreasing the in degree once we cover the prerequisite course. So this is a very brief description of Kahn's algorithm. Now we can proceed to the code and see it in detail. So our first task here is to build an adjacency list. So I'll just declare a 2D vector adj. So it will store all the uh, courses linked to a particular course. Next, we will also need to count the degrees of each of the node. So this will also be uh, num courses size, and we'll by default use 0 for everyone. And finally we'll see if a course can be taken or not. This we will mark in this array can be taken. So again the size would be the same and everything would be false by default. Now let's start by counting the integers and building the adjacency list. So I am going to iterate through the given requisites. So we'll extract all the edges given in the prerequisites array. So here prerequisites, and now. So the first thing is to increase the in degree of each of the uh, graph on which each of the course on which the other course is dependent. So for example, here uh, 0 is dependent on 1, so we need to increase the dependency of this course. So in degree h h 0 plus plus, and let me make it edges. So yes, next we need to add this into our adjacency list. So adjacency list is one one so basically the element on this index with a 1 has a course that is dependent on it, and which is course placed at the index 0. So we will add that into our list is 0. Now we'll start with the BFS thing. So for that we need a queue of int, and next we will check for the courses that are not dependent on any other course. So what I am going to do here is, if in degree of any course is equal to 0, we'll just push that number into our queue. Fine. And now we'll start with the BFS by exploring this queue we have made. So what it will do, it will go through all the courses that have 0 dependency. So for example, I will take out auto u dot front, and then we don't need it anymore. So we can see that u can be taken anytime because it is not dependent on anyone. So we will just mark it can be taken. Oh, sorry, can be taken u is equal to true. Our next task is to mark decrease all the in degrees of the neighbors of this course. So basically now that we have covered the course u, so whatever courses were dependent on u can now be taken if they are not dependent on any other course other than u. So what I'm going to do is iterate through all the neighbors of this course by making use of adjacency list we just created, and here our child node will be adjacent u. So first of all, since u has already been taken, so the dependency of the child v on u has decreased. So we have covered that dependency, so we can decrease the in degree by 1. And now if it is not dependent on any other course after this, so that what I mean to say is that if it in degree becomes 0 now, so we can add it into our um, queue just like this. So this will take care of all the courses that are independent once all its dependencies are covered. So this is all about BFS. Now for our answer, we can see that all the courses that can be taken have been marked true. So if we jump into any course that is not yet marked true after the complete iteration, or maybe to check can be taken if check is false, we'll return false. Otherwise, all the cases are satisfied and we return true as our default case. Let us check it. Okay, q dot front time is parenthesis here. In anything else? So it passed the test cases. Let's submit it. So yes, that was pretty much it, and this can be tagged in DFS, BFS, and topological graph. And also we covered Kahn's algorithm in this video. So hope you liked it, and see you tomorrow.